Hello, everyone. So we have a potential third nor'easter to impact the northeastern United States Monday night into Tuesday night. And originally, I wasn't thinking there was going to be one, and I will explain why. But now, based on latest model trends, I believe that there will be a potentially third nor'easter with significant impacts, especially along the coast. So looking at the NAM, to the north here is an upper level low that will serve as the steering mechanism. We've seen this plenty of times before. And then to the south, you have, this is where the models diverge. So you have a short wave here across Missouri, Arkansas, southeastern Oklahoma, northeastern Texas, and into western Tennessee. This is later tonight. So you have this short wave, and then you have all this southern stream energy here. Sorry, this isn't later tonight, this is later Sunday night. My mistake. So then you have all this southern stream energy here, sort of dispersed throughout the southeast. And the models are diverging on which of these actually creates the storm. The GFS says that this short wave diving to the south and east creates the storm. The NAM and the European model say it's all this southern stream energy that creates the initial storm. Now, how is that important for storm track? Well, firstly, you have to note that in order to get a storm to come up the coast rather than go out to sea, you of course want all of this energy, regardless of whether it's the short wave or the southern stream energy. You want all of this to get out ahead of the steering mechanism. You want it to come out ahead and come around the bend and come up. So that's how you get a northeast snowstorm. And so you'll see that in the new model runs. Originally, the old model runs had this upper low diving to the south and east too quick for this to round the bend and come up. And so this was being directed out to sea. So that was the old model runs. But the GFS is the only model that has held true to this, coming out ahead and coming up. And now the NAM and the European model are both trending towards that solution, rather than the out to sea solution. So then we must ask ourselves, is it this short wave that creates the storm, or is it all this dispersed southern stream energy that creates the storm? And why does this matter? Well, let's go ahead here on the NAM. First off, I do want to show you this. Pay attention to the location of this southern stream energy here. It's across Georgia, South Carolina, what is that? Alabama. That's Alabama, northwestern Florida. And then if you look at the surface map for the NAM, look at where the storm is. It's right where that southern stream energy is. Right here. All that southern stream energy is in this area. If you look at the GFS, your short wave is all the way back across Tennessee here, the center of the short wave where the upper low is. And then look at where the storm is. It's all the way back in Tennessee. Right in here. Notice, though, how you have an elongated area of low pressure in the GFS. So what that tells me is that the GFS is having a little trouble determining which energy is going to create the storm. Overall, it maintains that the storm, the center of the storm is going to be by that short wave, but it's having trouble with the interaction between that short wave and the southern stream energy. Excuse me. But looking at the NAM here, the NAM has a regular centered area of low pressure. It's not elongated. So the NAM and the European model both support that southern stream energy creating the storm. Alright, so now looking at the NAM, there is more room now for this to get out ahead of this, because it's further east, so my thinking is that there's more room for it to come up. Now notice what happens. Pay attention, it's all dispersed, but now you're going to notice a connection start to develop between the southern stream energy and the shortwave. All this energy is going to start coming together. Granted, your storm is still going to be over here, but the shortwave itself is going to start adding strength to the southern stream energy. So as you see that happen, see now it's all connected. This is early Tuesday morning now on the NAM. See, it's all connected now, and notice how it has come out ahead of the northern upper level low. So, why is this important? Well, let's look at the GFS. Going ahead here, there's a couple of things to note about the GFS. One, again, the GFS does show a bit of a connection between that southern stream energy and the shortwave, but remember that according to the GFS, it is this shortwave that is the primary creation mechanism for the storm. And notice how, once again, this is getting out ahead. So let's go to Tuesday morning. Okay, here it is. Notice how, first off, this is potent. This is a potent piece of energy. Then notice how there is a connection here to the steering mechanism. So now the steering mechanism can also transfer energy to the south and east to the storm and strengthen it. And so my thinking is that if the GFS is right, and it is that short wave rather than the southern stream energy that creates the storm, I think the storm is going to be stronger, slightly, not by much, because remember that, going back to the NAM, remember that the southern stream energy does eventually phase with the short wave. So that strengthens the storm in itself. However, the GFS has a connection to the steering mechanism in addition. So there's another source of strengthening there. And because of this connection, I think the storm, which has closed off in the GFS, it is not closed off in the NAM. You see, you don't see a closed contour in the NAM. So this is going to be further west. It's going to be drawn into the flow. It's going to be stronger. And so as a result, and I'm not going to show it for time's sake, but the GFS is indeed slightly further north and west than the NAM and the European model. So now you have to ask yourself, which solution is right? I don't know which solution's right, you know. Based on my knowledge of dynamics, I personally would think that it's the short wave that's the focus for the storm, because this is the more potent piece of energy here. I think even if the southern stream energy does initiate the storm, I think the focus of the storm is going to be taken over by this short wave as it rounds the bend and comes to the south and east. The NAM and the Euro are pretty consistent with keeping the center of the storm based on the southern stream energy here. Personally, I don't think that's right. I think the GFS is correct, and I think that the NAM and the European model are going to go towards the GFS over the next 24 hours. Because I do think that it is this short wave that is going to be the focus for the storm. It just makes more sense dynamically. Then you have to ask yourself, if that is so, what about this connection? Is this connection going to happen? And I guess that's yet to be seen whether that phasing is going to happen. The European model does show this phasing occurring, but much further to the north and east, and so the storm is slightly further to the east. But on the GFS, the earlier this phasing happens, the closer this is coming to the coast. And you'll have a stronger storm. Okay. So what do I think? I think this is going to trend west. I think that the southern stream energy, while it might create the initial storm, is not going to be the focus for the storm. I personally think that it's going to be this short wave that focuses the storm along the coast. And so, because of that, I do believe that this storm is going to trend further west. I also have confidence that this phasing is going to happen. Especially if the storm is the focus, if this shortwave is the focus of the storm, then I definitely think that this phasing is going to happen. Excuse me. So that's where we're at. So, over the next 24 hours, I expect this to trend further north and west. Looking at the surface map, though, I just want to point a couple things out. So let's do the GFS. This is going to be a strengthening storm. Pay attention to that number, 998. This is Monday afternoon. So, notice something here. Notice how late tomorrow night your storm is here. Remember, the NAM has it, NAM and the Euro have it down here. But then it transitions to right off the coast. And the reason for that is because for a moment, the GFS says, okay, that southern stream energy is passing by the coast here, and it is going to reform the storm off the coast. But then, notice how only for a couple more runs here, it is further east, but then it shifts, then it shifts back towards the coast as that shortwave rounds the bend. So it completely takes the focus away from the southern stream energy and puts it back on the shortwave. I think this is the correct solution. Excuse me. Alright, but the reason I wanted to show the surface map was to show the strengthening. So, pay attention to this number, 998. And we're on, Monday afternoon. Let's go ahead. Monday evening, 994. 983, Monday night, that's a big drop. 978. And by Tuesday afternoon, 972. So what is that? 998 to 972 is 26 millibar drop in 24 hours. So it's another bomb cyclone, guys. And then the other thing dynamically that I wanted to show, notice how you have this precipitation being pulled back all the way inland. And the reason for that, if you look at the dynamics, it's because of this connection. You have a negative, overall the trough axis has gone negative, and because of this connection, now you're going to have moisture being pulled back from the ocean inland, like that. And then the other reason is with an upper low over here, you're going to have upward motion on the eastern side of that. So even without a storm, you would be getting snow showers across the Great Lakes in Pennsylvania in here. So that connection is really going to help pull, and the negatively tilted trough is going to help pull that moisture back inland. Alright, so I already explained that I think the storm is coming further north and west. So, I'm going to make this threat map here. I don't feel confident enough to post an accumulation map yet because I just want to see what the models do tomorrow. But here we go. Your potential for 6+ inches is going to be closer to the coast where the storm is. I think your heavier snow bands are going to be here. But you also have to remember that the models, when you have a bomb cyclone, the models are always going to underdo the precipitation on the western side. So that's what I'm concerned about with this, and that's why I'm not posting a snowfall map yet. But this is my threat map. So your potential for 6+, I'm taking it... Hold on a second, I just lost my... Why is it always going to do this? I just lost my menu. There we go. Sorry. Occasionally what Screencast-O-Matic will do is, so I have a menu on the bottom left side here with the pause button and see how much time I've gone. Sometimes Screencast-O-Matic will make that disappear on me. I have no idea why, and it's really annoying. Also, it takes away my pen tool, so I can't draw. Anyway, so the potential for 6+, I'm taking it right through New York City. So all of Long Island is going to be in the potential for 6+. I'm going to bring it right through the lower Hudson Valley. I'll bring it right through Hartford, so Hartford will be on the western end. Right through central Massachusetts. So Worcester, Boston will all be in it. Most of Connecticut is in it. Providence, Rhode Island, and all of Cape Cod. In fact, even in here is definitely a potential for 6+. So watch out there. I'm bringing it back into New Hampshire here. And the reason for this orientation is, remember that it's a negatively tilted trough, so you will be having, even though the storm is taking a northeast track, you will have precipitation coming back further west. So that's why it's oriented like this. And then all of Maine is in the potential for 6+. So major cities, New York City and Boston, are the two major cities that are in the potential for 6+ inches of snow. And then your potential for 3+, I'll take from southern New Jersey back towards eastern Pennsylvania. I'll put Philly in the potential for 3+ for now. Might be a little too far west. Albany will be in the potential for 3+, a good portion of central New York State, all of Vermont. Okay? So that is the threat map for now. Forgot to mention. That's what I forgot. I knew I was forgetting something. As this piece of energy, even if it's not the focus for the storm, which I think it will be, though. As this piece of energy dives to the south and east and rounds the bend, you have to watch out on the northern and western side of this for a period of snow, Sunday night into Monday. It's going to be in here. And I'll show it on the surface map too. So in this area, so western and central Tennessee, southern Indiana, Illinois, Ohio, all of Kentucky, all of West Virginia, and a good portion of central Virginia into southern Maryland, including Baltimore and D.C., and parts of Delaware. As this shortwave moves to the east here, to the south and east, you need to watch out for a period of accumulating snow Sunday night into Monday. And I think it's going to be like a 1 to 3 or a 2 to 4. Because the storm isn't really, strengthening yet. So I think this is a 2 to 4 at most. At most, I don't think anybody gets more than 6 inches. But I think this is a 1 to 3 or a 2 to 4 Sunday night into Monday. So we can watch that on the NAMC. By late Sunday night, you can already see your snow developing into western Tennessee and Kentucky. And here we go, moving forward. You see it moves to the east here. Now, the NAM still thinks the southern stream energy is the focus of the storm. What about if the GFS is right and the and the shortwave is the focus of the storm? So here we go. You're going to have heavier snows breaking out in this area here. That is, again, Sunday night, tomorrow night. You have heavier snows breaking out because your surface low pressure is literally right here over Tennessee. And as that moves to the north and east and reforms off the coast, you still got to watch out for an area of snow to go in here. So watch out in this area for Sunday night into Monday for a period of accumulating snow. Alright. Now, the other thing I wanted to mention is the fact that you have high pressure, but look where it is. It's all the way back here. So there's nothing securing cold air in place. So especially along the coast, if you want heavy snow, dynamic cooling is going to play a role. Remember, as you have a strengthening low pressure system, on the northwestern side, you have strong upward motion, which leads to dynamic cooling, which can outdo the heating coming in from the ocean. So you want that to play a role. Now, from Thursday's nor'easter, we do have a cold air mass in place. I'm just not sure how secure it's going to be because your high is all the way to the west. So if this area of low pressure, if our storm continues to transition further north and west, you might have mixing problems along the coast here, which could hold down snow accumulations. So let's see if that happens. The other thing to watch out for, and I'll try to do more details with this tomorrow because this video is already 21 minutes long. As this strengthens, you're going to have gusty winds along the coast. There's going to be coastal flooding. It's going to be a friggin' mess. So just let's keep an eye on this and see what happens. I'll post another video tomorrow.